Understanding how militaries locate these voids requires looking at the environment they are up against. Southern Iran's Zagros Mountains are a chaotic maze of jagged limestone cliffs, a topography that naturally swallows entire subterranean networks. If you rely on normal optical satellite cameras or standard ground radar, you'll hit a wall. Heavy rock layers and intense maritime humidity degrade those signals until they are effectively useless for deep reconnaissance. To map this terrain, coalition forces deployed high-altitude endurance platforms, stealth drones that circle miles above the peaks, scanning the landscape from above. Finding these buried secrets depends on using technology capable of piercing the Earth's crust, rather than relying on tools that only see the surface. That technology is LiDAR, or light detection and ranging. The system operates by firing hundreds of thousands of rapid laser pulses per second directly into the ground. By measuring the exact travel time of each reflected pulse, it constructs a point cloud, a high-resolution, three-dimensional digital model of the world. Because the pulses are so dense, they slip through microscopic gaps in vegetation, rocks, and camouflage netting to strike the solid Earth below. This creates a microtopographic anomaly map. Since the model is accurate to the millimeter, it reveals where soil has been recently excavated, moved, or disturbed. For a modern treasure hunter or archaeologist, this provides the ability to scan a mountainside and spot exactly where a secret cave was sealed or where Earth was manipulated centuries ago. To a LiDAR sensor, surface barriers like heavy brush or fake terrain are effectively non-existent. Natural concealment no longer offers protection. But mapping the bare Earth is only the first step. You must determine if a rock formation is solid or if a hidden cavern lies underneath. This is where volumetric analysis comes in. The system calculates the exact three-dimensional density and internal structure of a target. Military units use this capability to distinguish between a hollow fabric decoy launcher and a massive solid steel armored vehicle. For an explorer, this allows for the mapping of reinforced subterranean tunnels and hollow mountain bases without ever moving a single rock. This penetration extends into the water. While standard sonar distorts in shallow, murky coastal areas, specialized bathymetric LiDAR uses a blue-green laser spectrum to pierce the water column. Militaries used this specific laser spectrum to detect submerged objects in the shallow Strait of Hormuz, such as midget submarines resting below the surface. Whether identifying a hollow cave inside a mountain or uncovering submerged ruins, the technology strips away physical layers to expose the volume beneath. With a laser grid that maps both surface anomalies and internal volumes, the question becomes, can the Earth hide anything at all? To counter these scans, defensive forces deploy heavy chemical aerosol smokescreens over facility entrances. These fog generators release microparticles calibrated to absorb and refract the specific infrared wavelengths used by the lasers, blinding the airborne sensors. The second reaction to LiDAR mapping is subterranean depth escalation. Since shallow bunkers are now transparent to scanners, targets are forced to dig deeper into solid rock, which significantly increases the logistical difficulty of concealment. Overcoming these defenses is no longer a matter of physical searching. It has become an arms race between optical sensors and light-scattering technology. For the modern explorer, finding underground voids and ancient caches is a precise mathematical science of bouncing light. This shift in technology has changed our ability to see through the Earth.
With their subterranean mountain networks exposed by orbital LiDAR arrays, the tactical theater rapidly spilled over into the most sensitive maritime transit corridor on Earth. This animated map highlights the new arena of conflict, the Strait of Hormuz. Measuring 21 nautical miles wide at its narrowest point, this single geographic gap serves as the maritime highway for roughly 20% of the world's petroleum consumption. In response to precise aerial pressure, aggressive maritime interdiction became the primary doctrine. The waterway was rendered a combat zone by fast attack craft swarms that maneuvered around massive commercial tankers. These small crafts operated alongside layered area denial threats. Shorelines were fortified with coastal batteries firing anti-ship missiles directly from the sand, while naval mining operations saturated the depths. The global market reaction was immediate. Commercial shipping consortia halted transit routes through the Persian Gulf, and international marine insurers canceled their war risk coverage. To the outside world, this appeared to be a calculated seizure of a strategic choke point, designed to lock the global economy away from its primary energy source. The entire blockade relied on the strategic assumption that sealing the strait would instantly starve foreign powers of energy and force them into capitulation. But modern global logistics had already built a workaround. Neighboring Gulf states could bypass the maritime choke point by routing their petroleum through massive overland pipelines. Western and Asian economies also tapped into their own domestic hoards. They utilized strategic petroleum reserves to absorb the sudden drop in maritime supply. Energy markets braced for volatility, and prices spiked. Yet ultimately, global supply chains adjusted their sourcing and kept moving. Modern economics effectively redrew the map. The world simply walked around the barricade, leaving the trap unsprung on the global stage. But while the global stage absorbed the shock, a severe, cascading reality was unfolding inside the blockaded nation. Iran suffers from a critical structural vulnerability, a total lack of alternative export routes. They rely almost exclusively on southern sea terminals, like the storage tanks isolated here on Karg Island, to move their crude oil. Because the strait was actively mined and contested, their own fully loaded oil tankers sat idle, unable to reach international buyers. Halting those exports triggered a macroeconomic crisis. It severed the flow of hard foreign currency entering the national treasury. Without that vital foreign exchange flowing in, the national currency went into an inflationary spiral. Local free markets experienced rapid hyper-devaluation, eroding civilian purchasing power within days. Then came the supply shock. The Strait of Hormuz is a dual-purpose channel. It serves as an export corridor, but it is also the vital import gateway for the entire nation. By shutting down maritime traffic, the blockade physically interdicted its own supply lines. Sprawling docks and industrial ports were cut off from global logistics. Essential food supplies, raw materials, and refined components stopped arriving. These shortages drove industrial stagnation and forced widespread factory closures. By slamming the door to hoard their leverage, they blockaded their own supply lines and suffocated their own domestic economy. This diagram shows the different outcomes of the conflict. On the left, a resilient global market makes brief adjustments. On the right, a fragile domestic economy structurally collapses. The asymmetric damage inflicted internally was devastating, resulting in the permanent loss of key Asian energy markets. In the tactical theater, tools like LiDAR secured battlefield visibility by eliminating physical hiding spots. However, the turning point of this conflict was entirely economic. Disrupting a vital trade corridor results in a structural shock that destroys the domestic foundation of the nation attempting the blockade. Attempting to use a geographic choke point as a weapon effectively traps the vulnerable nation within its own blockade.